Hello, welcome to lesson 6. In this lesson, we are going to look into images formed by the concave mirror, images formed by a convex mirror, uses of curved mirrors, and then advantages and disadvantages of curved mirrors. Let's begin by looking at the images formed by a concave mirror. So, we are going to be following the rules in order to get these images. We're going to follow the rules that we discussed in the previous lesson, and then we shall use those rules to get the nature of the images formed. So let us look at this. When the object is placed between F and P. So we're going to start by looking at when the object is placed between F and P, because the nature of the images formed always depends on the position. The nature of the images formed by a concave mirror always depends on the position of the object. So if the object is placed between F and P, then this is what we are going to have. That's what we are going to have. So what are we saying? How are we going to come up with this? First of all, we are going to draw our plane mirror, our concave mirror here, and then we draw this axis, which is the principal axis. Then we shall place our object between P, so that between F and P. Then we place our object between F and P. Then we are going to follow the rule. So we are going to do all the rays drawn must be drawn from the top of the object. All the rays drawn must be drawn from the top of the object. So first of all, the top of the object is A. It's at A here. So the object is OA. So the top of the object is A. So we are going to draw using the rules. So the first rule which we looked into, we shall draw a ray parallel to the principal axis is reflected through the principal focus, as you can see. So this ray is going to be drawn from the top here to the mirror, and then it's going to be reflected in that direction, and then we shall elongate it. It will be appearing to come from this other side. Then also another rule you are going to use is that usually we use two rules to come up with the image. We can't use only one rule. We always come with two rules, because the two rules gives you the two ray diagrams, or the two rays which meet. So there must be meeting of two rays in order for it to form an image. So we shall follow this other second rule. Of course, the second rule, according to what we discussed, may not help, but now we look for a rule which is going to help in this case. Now, for example, we already have this point, so we are going to draw a ray through the center of curvature and the top of the object, and then that ray will be reflected along the same path. Following the third rule, it will be reflected along the same path, and then it will appear to come from somewhere here. So when we elongate this, we'll elongate this where they are coming from, elongate them, they will meet at a certain point, and where they meet is where the image is going to be formed. So that's how you come up with the image. So let us see. The nature is going to be behind the mirror. The nature of the image is going to be, first of all, behind the mirror. It is going to be virtual, as you can see. It's going to be erect, and it is going to be magnified. And then also let us look at the next one. That is when the object is at F. When the object is at F, we are going to draw still the mirror, and then the principal axis here, and then we shall have something like this. So following the same principle, we shall also have our object at F. So the top of the object is A. Draw a parallel ray from A to the mirror, and that ray is going to be reflected through the principal focus, as discussed in the first rule that we discussed in the last lesson. And then also the second one is this time around we are going to use the second rule. We're going to use we're going to use the third rule, and the third rule states that when a ray passes through the center of curvature, and then through the top, we shall draw it from the center of curvature and through the top of that object, then it is going to be reflected along the same path. So when you look at that, these two rays, if well drawn using a ruler, they are going to be parallel. And if they are parallel, it means that we are not going to have a meeting point, and so the meeting, we shall say that the meeting will be at infinity. So these rays will go to infinity. So those rays will go to infinity. So always when you are drawing these rays, you're not supposed to forget the arrows, as we discussed in our first lesson, that these arrows are the ones which shows the direction of path. So we need to include the arrows. Let's look at the nature of the images formed. The images formed, first of all, you have seen they are formed at infinity, and also they are virtual and upright. Next, let us look into the next case where we have the object between F and C. When the object is between F and C, then you're going to see that we have still this. So let us see how we can come up with the image here. So first of all, let us draw our object at this point between C and F, or between F and C. From the top of the object, draw a parallel ray to meet the mirror surface, and then it is reflected through the principal focus. Then also a ray passing through the center is reflected along the same path, but all these rays must be passing through the top of the object. And then when you see this is reflected along the same path, and this one is reflected along this, so they meet at a certain point here, and then we form the image. So the image will be here. So the nature of the image in that case, the nature of the image is going to be formed beyond C, as we are seeing there, and it is going to be real. It's going to be formed beyond it is beyond C. It is real. It is inverted, as you can see, and it is also magnified, as we are seeing there. Let's look at the next case where the object is at C. When the object is at C, then we draw our object at C. So this is the object at C. Draw that object here, and then draw a ray parallel to the principal axis. It's reflected through the principal focus, and then a ray through the principal focus is reflected parallel to the principal axis. Where the two rays meet, they form the image. So the image is going to be here. So when you look at the nature of that image, you can clearly see that it's going to be at C, and it is going to be real, and it's going to be inverted, as you're seeing there, and then it is going to be the same size as the object. Let's look at the next case where we have the object beyond C. So when you place the object beyond C, this is what you're going to have. The object, this is the object, this is C, and then the object is beyond C. So the same thing, a ray parallel to the principal axis is reflected through the principal focus. Then a ray through the center of curvature, from the top of that object to the center of curvature, is reflected along the same path. Where the two rays meet, that is this and that, you can see they are meeting at that point, and that's where the image is going to be formed. So in that case, the image is going to be between C and F, and you can see that it is real, it is inverted, and also we can see clearly that it is diminished. Let's look at the next case when the object is at infinity. So when the object is at infinity, so we are going to draw our rays from infinity. At infinity, we shall just bring two rays from infinity. The first ray is going to be this one. Now remember, when the rays from infinity, in that case, these two rays are from infinity, they are going to be reflected according to the laws of reflection. And so it is going to be reflected according to the, if it meets this at maybe an angle I, it is have to be reflected at an angle I to that normal there, the normal at that point. And so the same to this one, it is going to meet this pole at a certain angle, and it's going to reflect it at the same angle. So where the two rays meet is where the image is going to be. So when you observe this, the image is going to be formed at F. The image is going to be formed at F. And that image, so the nature of that image is going to be formed at F, and it is going to be real, it is going to be inverted, and also you can see that it's going to be diminished. Let's look at when we have a convex mirror. Now, for a convex mirror, the nature of the image will always be the same. The nature of the image, no matter where the object is placed. No matter where the object is placed, the nature of the image will always be the same. So this will always be, as you can see, let us first see how the rays are also following the same principle. if we place at this is the object, if this is the object placed at any distance in front of this mirror, any distance in front of the mirror, we place that object. So a ray parallel to the principal axis is reflected through the principal focus. So it is going to be, since it is a diverging mirror, it is going to diverge and it will appear to come from that F here, from the F. So, and then also a ray passing through the center is reflected along the same path. So it will be reflected along the same path. So the two rays will appear to meet at this point here, and therefore the image will be here. So generally we can see that the image there is erect. It is virtual because it's formed by a par intersection of light rays, and then also it is diminished. Now, in addition to that, convex mirrors also has what we call a wide field of view. A wide field of view is what we are talking about. That's a wide field of view. So you can view over a wider area. If we compare with other mirrors, this one helps you to view over a wider area. And this property here is very, very important. Let us look at the uses of curved mirrors. Firstly, let us begin by looking at the uses of the concave mirror. So the concave mirror can be used as shaving mirror, because when we place, remember when we place the object between F and P, the image formed is magnified, is virtual and erect. So in that case, it can be used as a shaving mirror. It can also be used by dentists for teeth examination using the same principle because it is magnified. And then also it can be used in solar concentrators. In solar concentrators it's used. In solar concentrators, of course, solar concentrators, these are for the solar panels. Yeah, these are solar concentrators for the solar panels, or in the solar panels. And then they are also used in reflecting telescopes, a device for viewing distant objects. They are also used in projectors, a device for showing slides on a screen. Let's go ahead and look at the uses of convex mirrors. For convex mirrors, as we have already seen, that kind of wide field of view helps it to be used as a driving mirror. It's used as a driving mirror. It's also used in reflecting telescope, a device for viewing distant objects. It's also used in supermarkets to observe the activities of customers, and then it's also used in security checkpoints to inspect under vehicles. This is very common in the security checkpoints. We have also here we're also going to look into the advantages and disadvantages of curved mirrors. Let's begin by looking into the advantages of the concave mirror. The concave mirror forms a magnified and erect image. That is a big advantage. It forms a magnified and erect image. And then also let's look into the advantages of a convex mirror. First of all, one of the advantages, we have already seen that it has a wide field of view. Has a wide field of view as compared to the plane mirror. It has a wide field of view. If this is a plane mirror, the view of a plane mirror is narrow. The object must be within a narrow space. But for a convex mirror, it has a wide field of view. We have another advantage of convex mirror apart from the wide field of view. The other advantage is that the image formed is always erect. Image formed is always erect. Let's also look at the disadvantage of convex mirror. The major disadvantage of the convex mirror is that when you look at the image formed, it is always diminished, and because it is diminished, it gives a wrong impression of the image or of the object behind. So it may give a wrong impression of the distance of that image or of that object behind. So you may think that maybe it is in a narrow or in a short distance, yes, it is at a long distance, or you may think that it is at a long distance, it is at a short distance, so it gives that wrong impression. Thank you. See you in the next lesson.